principal, the academic coordinators of both the Department of Business Administration and Commerce, the other faculty members, HODs of other department, other HODs, and professors from other departments of our institution, and the resource person for today's international seminar on pandemic analytics, how we are going to, how this data is going to help us to combat this COVID-19. So we welcome you again. We welcome the students also. We request the students to kindly please speak in silence. Before getting into the program, I request the choir girls to come and sing the prayer song. That's all. Nice to read for the program.
This is the promise of love. There shall be seasons refreshing, sent from your Savior above. Showers of blessing we need. Mercy from the sun falling, but for the showers we bleed. But for the showers we bleed.
Again, a very pleasant good morning to all. It is indeed a great privilege for me as the head of the Department of Business Administration, as well as the convener of this international seminar on pandemic analytics, how data is helping us combat this COVID-19. So as you all know, we are living in this pandemic period. So we thought that pandemic has gone out. By 2019, it hit in Chennai, it hit in China in the month of December 2019. Later, all over the country, we were facing with this pandemic situation, and we thought that it has been settled, but it is not settled. Again, we are going to have a second cycle, which is right now we have entered already, and the government is planning either to go for lockdown or not, what else to do, and the entire educational scenario has been like ruled out because of this pandemic situation. So in this case, I recommend we, the Department of Business Administration and Commerce, jointly we plan to come up with a wonderful international seminar on pandemic analytics and the data what the government is giving. Every country has their own data, and what the government is giving this particular data, how we can predict this data, how we can analyze this data, and so that we can combat this COVID-19 situation all over the country as well as across the globe. So this is what the main theme of this particular seminar. And on behalf of Geetha, Jeevan, College Management, Principal, and my own behalf, and on behalf of the organizing committee of this international seminar, I welcome the resource person of today's international webinar, Mr. Jeevan, who is the Senior Engineer and Architect, Cardinal Health INC, Cleveland, Ohio, from the United States of America, who is joined with us on a virtual mode today. So he is there to address us. Again, we welcome you, sir. Next, I would like to welcome our beloved principal, Dr. S. Mullarpudi, who is always a source of inspiration and support for us in all the endeavors, either as an academic or non-academic activities. Whenever we go and approach her, she is immediately, with a smile, she will be accepting all the proposals. So we thank you, ma'am. So we welcome you also, ma'am, for this international webinar. Next, I would like to welcome the organizing committee, the organizing secretary of this international webinar, Dr. P. Sudha, who is also an academic coordinator of the Department of Commerce. We welcome you, ma'am. I would like to welcome the co-organizing secretary of this international webinar, Madam Mrs. Geetha, again an academic coordinator of the Department of Business Administration for this August presence. Welcome, ma'am. I would like to welcome professors from the Department of Commerce who have joined with us, and professors from the Department of Mathematics also who have joined with us. Last but not least, I would like to welcome all the students, both from the Department of Commerce as well as from the Department of Business Administration. And we have two students from the Department of Mathematics who have joined with us today. And again, on behalf of the entire faculty members of the Geetha, Jeevan, College School of Learning, I welcome you all again. Thank you. And we have few participants who are research scholars from Saranagar College, who have also joined with us. So we welcome those research scholars also for their august presence. So I request our beloved principal ma'am, Dr. Thoothukudi ma'am, to go to the presentation lectures. Over to Dr. Thoothukudi.
Good morning to all of you. We are all operating in unprecedented times due to the effects of coronavirus disease, that is COVID-19, in society and our workplaces. The sheer fluidity of change forced us to deal with in the month of March alone seems surreal. It is bewildering to think that a seemingly isolated number of cases in Wuhan and in China reported to the World Health Organization on December 31st, 2019. Now, meteorologically risen to nearly 330,000 confirmed cases and 14.4 thousand deaths across over 180 countries as of Sunday, March 22nd of 2020. As society grapples with the public health and economic challenges manifesting in COVID-19, businesses rushing to realign themselves to this new reality are looking for technology to help. Data analytics in particular is proving to be an ally of our epidemiologists as they join forces with the data scientists to address the scale of the crisis. The spread of COVID-19 and the public's desire for information has sparked the creation of open source data sets and visualizations, paving the way for a discipline introduced as pandemic analytics. Analytics is the aggregation and examination of data from many sources to derive insights, and when used to study and find global outbreak, pandemic analytics is a modern way to combat a problem as old as humanity itself. That is the population of disease. Here are 3 ways analytics are helping us to get through the COVID-19 crisis. First one is to craft the right response. In the early 1850s, London battled a rampant rise in the number of cholera cases. John Snow, the founder of modern epidemiology, noticed cluster patterns of cholera disease around water parks. This discovery allowed the scientists to leverage data to combat pandemics for the first time, driving their efforts towards quantifying the risk, identifying the enemy, and devising an appropriate response strategy. The early flash of genius has since advanced, and 170 years of cumulative intelligence has proven that early interventions disrupt the spread of disease. However, analysis, decisioning, and its subsequent intervention can only be effective when it first takes into consideration all accessible or meaningful data points. At Sheba Medical Center in Missouri, healthcare administrators are using the data-driven forecasting to optimize the allocation of personnel and resources in advance of potential local outbreaks. These solutions are powered by machine learning algorithms that offer predictive insights based on all accessible data about the spread of the disease, such as confirmed cases, test results, contact tracing, population density, demographics, migration flow, availability of medical resources, and pharma stock rates. Viral spread has a small silver lining, the exponential creation of new data, which we can learn from and act upon. With the right analytics capabilities, healthcare professionals can answer the questions such as where the next cluster is most likely to arise, which demographic is the most susceptible, and how the virus may mutate over time. To see the unseeable, The accessibility of data from trusted sources has led to unprecedented sharing of visualizations and messages to educate the public. Take, for example, the dynamic world map created by Johns Hopkins Center for Systems, Science and Engineering, and these brilliantly simple yet enlightening animations from the Washington Post. Such visualizations are quickly teaching the public about how the viruses spread and which individual actions can help or hinder that spread. The democratization of data and analytic tools combined with mass ability to share the information via the internet has allowed us to witness the impressive power of data used for good. In recent months, companies have brought pandemic data gathering in-house to develop their own proprietary intelligence. Some of the more enterprising companies have even set up internal threat and response command centers to guide their employees, customers, and broader partner ecosystem through the current crisis. HCL realized early in the outbreak that it would need its own command center dedicated to COVID-19 response. Coordinated by senior leadership, it gives HCL data scientists the autonomy to develop creative and pragmatic insights for more informed decisions. For example, developing predictive analytics on potential impact of HCL customers as well as the markets where the HCL services them. With the goal of enabling the leadership to respond quickly throughout the development of the COVID situation, we employed techniques such as statistics, control theory, simulation modeling, and natural language processing. For simplicity, we all categorize our approach under the track and response umbrella. Track the situation quantitatively and qualitatively to understand its magnitude. Perform the topic modeling in real time across thousands of publications from international health agencies and credible news outlets. Automate the extraction of quantifiable trends, that is alerts, and actionable information relevant to the manager's role and responsibility. Create forecasting which will directly track and predict when regions critical to HCL and its customers will reach peak infection and conversely a rise in recovery rate. Respond using a mathematical model of the situation as a proxy for the actual pandemic. Create a multidimensional simulation model using robust and contextual variables to produce a meaningful prediction customized to the leader using it. To diagnose, treat, and cure on December 21st, 2019, an artificial intelligence system operated by a Toronto-based startup called Blue Dart detected the earliest anomalies relating to what was then considered a mysterious pneumonia strain in Wuhan. The artificial intelligence system accessed over 1 million articles in 65 languages to detect a similarity to the 2003 SARS outbreak. It was only 9 days later that the World Health Organization alerted the wider public about the emergence of this new data. Developing a healthcare solution is a challenge of analyzing data at scale, and this is where the AI, that is artificial intelligence, can play a crucial role. AI technology has already been deployed to help diagnose the coronavirus through imaging analysis, decreasing the diagnostic time from CT scan results from about 5 minutes to 20 seconds. Through automation, artificial intelligence can not only help cope with the rising diagnostics workloads, but also free up for treating the patient. AI and ML can also be used to speed up the pharmaceutical development process. So far, only one artificial intelligence, that is AI, developed drug has reached human clinical trials. But even that solitary success is extremely impressive, as the technology was able to expedite a process that typically takes years. It's quite possible that AI in conjunction with medical researchers can help reduce drug development timeliness to mere months or weeks. With the world still in urgent need of a COVID-19 vaccine, months after first reported death, this human machine synergy in the pharmaceutical space is the need of the where we go from here. As the world braces itself for the impact of COVID-19 outbreak, it is important to remember that technology is nothing but the cumulative innovation of humanity over time and in technology. We have the tools necessary to help us survive and protect ourselves. We do not know what lies in store for us in the coming weeks and months, but we will face it together, and our greatest strength will be in how we share, analyze, and derive insights from our shared knowledge. With the right technology applied in the right direction, we have the potential to contain and minimize the impact of disease today and in the future. And with these great insights, I congratulate and compliment the Department of Business Administration and Commerce for arranging this wonderful seminar for the right selection of the topic, which is again the need of the hour. Once again, I thank you all.
Thank you, Principal Ma'am, for the nice presentation, which have made the students to think over the pandemic situation. Thank you, ma'am. Now it's time for introducing our subject for this opportunity. I recommend our Madam Mrs. Dhanalakshmi, the Coordinating Secretary of this international webinar, as well as the academic coordinator of business education, to introduce the chief guest, the August.
Cordial helping client and OPR business. He has over 22 years of experience working in information technology. Prior to Cordial Health, Jeevan worked as a project manager in IGTE Americans, implementing Oracle ERP applications at GE, character engineer C19. Jeevan graduated in production engineering from PSC College of Technology, Coimbatore, and did his master degree in business administration from ICFAI, Geetha. At present, Jeevan lives in Thailand along with his wife and 2 boys. In his leisure, Jeevan loves to read books and engage in social media or current affairs and love wildlife photography.
Thank you, madam. I recommend our research person, Mr. Vivian, to kindly take the
Right. Good morning, everyone. Just want to confirm if you are able to hear me.
Fine, sir. Fine.
All right. Okay. I really want to thank you all for giving me this opportunity. And it is really a great pleasure to talk to you all. So let me start the presentation. I will share my screen. Are you able to see?
Yes, sir. It's visible, sir.
All right. So let me give a brief introduction about me. I know I really appreciate you taking the time to introduce me. And let me just give a brief introduction. So I work as a senior engineer, as a data architect at Cardinal Health in the United States, actually. So this is located in Ohio, state of Ohio, and I've been working here from 2014. Before this, I was working in Patni Computers back in India, and then in iGate Technologies, which was actually, Patni was taken over by iGate in 2011. So I was in Patni and then in iGate for about 14 years. So I worked as a project manager there, and Oracle ERP was my area of expertise. We were implementing it in many clients. So I came to the US in 2006 through Patni Computers. And before that, I was in, when I came out of college in 98, in Godrej Infotech Limited, and it is located in Mumbai. So I got placed in Godrej through campus. So that's where I worked for the first 2 years of my career as a program analyst. So about my education, I did production engineering from PhD College of Technology. I'm sure you all know about the college. It's in Coimbatore. And I later on did master's in business administration also. So that's about me. And let's go over to the topic. And so just to give a brief overview of how this pandemic is going on right now, is like COVID-19 started off in 2000, end of 19 and 2020. So we have, as of today, I was just checking the numbers, it was like 122 million cases. So the world population is approximately 7,700 or 7,800 million right now. So we have about 1.6% of the world population which got affected. You know, maybe a little more because we may not have got all the cases. And then there is like 2.69 million people have died. So this is like a huge, thing for us, and a lot of impact has happened. A lot of people have, a lot of impact on the jobs and business and economy and so many things. But if you compare this number with the Spanish flu, which happened like in 1918 and 1919, so almost 1/3 of the world was impacted by that, like 500 million cases, they say. We don't have very good data from then, but based on the numbers that we have, they predict that at least 33% of the world would have got affected by the Spanish flu. And the number of people who died is not recorded very well. There's a lot of difference in the number, but they say it could have been even 50 million. So as you can see the numbers, although COVID-19 is very, for us, it's a big thing. It's a big pandemic. We have been able to control it much better. Like you can see that we only less than 2% of the world has got affected today. After 1 year, we still are less than 2%. And so compared to the Spanish flu, we have this COVID-19 very much under control, right? So if you see, there are many reasons why it happened, right? So like, how did we control this pandemic, that we did not let it go really worse like the Spanish flu? So of course, there is a lot of medical advancement today, right? So we have hospitals have, several medical equipments, ventilators have come. These were all not there during 1918. And we have drugs, several drugs, antiviral drugs, right? Even bacterial antibiotics were not there back then. So drugs and vaccines. So right now we have so much of development around that. And hygiene itself was not, well defined at the time, how to maintain hygiene even in hospitals, or the kind of hygiene that we have today. It was not even, known at that time. And we were very good in doing like lockdowns and quarantining people. So if you think about how they try to quarantine with not enough hygiene and not clarity on how, they were not able to test the people properly. There wasn't easy way to quarantine people back then. So, and apart from all this, we also have the information technology today, which is the world is connected, right? We know how the pandemic is spreading. So there is sharing of data from different countries, and even to develop a drug or a vaccine, there is a lot of data sharing between hospitals. And so that kind of enables us to, with the information technology, we have the information, right at our hand, so we can take action so quickly. So that's one important aspect of how the world is all very close. Earlier they wouldn't have even known how the pandemic is spreading. It was spreading in the US, so nobody in the other part of the world would have known what's happening, right? So apart the thing we are going to talk about today is the data part of it. So big data and machine learning. So that's the part we are going to cover today. So that has played a major role, although it's not, visible for us in the behind the scenes, right? So it has played a big role in many of the ways in which the pandemic has been controlled. So that's going to be our main topic today. And so you can see that, so we talk about so much about this concept, this new machine learning and big data everywhere today, right? It's not only during the pandemic, it was very popular even before the pandemic. It's used in all industries, right? So let's quickly, go to some basics. I do not know how many of you are very well versed with this, so I just wanted to just give a brief overview, very short overview of some basic concepts, and then we'll go into the depth. So what is data analytics? I'm sure, this is a common thing. So you all might have, you all might be knowing these steps, but so it's basically a collection of data, right? So we need to find out what are the sources of your data, right? From where you are going to get the data. So data collection is the key aspect of data analytics, because that's where you, the data can be like, it's going to give you either the correct results, or if the data itself is not accurate, everything will go wrong, right? So it's important to understand how your data collection is going to be, and to avoid errors and avoid any data which is having, not defined in the correct way by different sources. So we can look at it in detail a little bit more, but data collection during the pandemic has been very critical, and all the countries which have a good way to collect the data, so they were able to measure the pandemic and control it much better. So then we have the data transformation. So we do transformation because data comes from different sources. It may not have all the fields, like say you are getting a file from a particular hospital or from a particular clinic, or, so they may not have all the, fields, and that could be different fields which are, populated in different formats. The files may be in different format. So there will be data cleansing that is required. And there will be some transformations required. You may have to arrive at some data which is not explicitly given. You have to derive some data. So all this happens in the data transformation stage. So today we have a lot of tools to do this data cleansing. And the third important thing is data storage. So one big thing that happened in the information technology is the cloud storage, right? So cloud is a huge revolution that happened, that people were able to get storage in huge volumes, right? So earlier we were storing data in our own database servers, right? And there was a limit on how much you can store, and there were issues of performance and all that, right? So, but cloud technology gave us the opportunity to store data in very huge volumes actually, and that kind of revolutionized the whole data analytics part. So cloud, as you all know, is it's offered as a, so you kind of pay for the service, right? So cloud is like, you can think about like Google. So you can go to this Google Drive and you are storing data there, right? So, something like that, where cloud is offered as a data storage. They are giving you as a service, and you pay for the data that you store. And it is very flexible and elastic. So if you want to store more data, they will just add more data storage there. So you can keep on adding as much storage as you want, because you are not storing it in your server, you are storing it in the cloud. So cloud is maintained by Google or Amazon or whoever it is. And they have this huge computing power. So cloud gave the opportunity to use many computers, which are, you can select what kind of computers you want to do the performance. So these storage and computing are two important things that the cloud technology gave, which was not there before, and we were not able to do much of big data analysis without cloud. So that's the part of data storage I wanted to bring. And there is data analysis, which we have, like we write queries, and there are many tools to write, to build analysis of get information from the data, like, some to take some decision. Then there is data visualization. We have this Tableau and other tools which, display graphs and other ways in which you can display the data, right? So these are basically the 5 steps in the data analytics. And so a quick going over the history of data analytics, right? So, I mean, I don't know how many of you know how these things used to be, but in the beginning, when I came to my first job in '98, so we had online transactional processing, like the relational databases, like Oracle. We had all these relational databases which had reporting done out of them. So there was no data warehouse at that time. So we write programs which will bring out reports, and that's the same database which will be used for transactional processing also. So the reporting was not very efficient because the database had all the keys and data integrity, right? So different parent-child relations were all good for transactional processing, but for reporting it was not very good. So, but that's what they used. They never had a separate data warehouse. So then came the period where data warehouses became very popular. Like, this star schema, where you can see this picture here. They have the facts and dimensions, so they can store data in a different format from transactional processing. So this was separate. So every day there was a batch running where it pushed all the data from transactional databases to data warehouse. And then people can run reports out of data warehouse. So then after a while, there is business intelligence. BI became very famous, with users can actually build their own like kind of graphs and other visual tools, and more or less like that. It gave more power to the users to build their own reporting in a very visual format, right? So business intelligence came, and it was very good for the people in the higher positions in the organization to get a visual representation of the data and for them to take decisions. So after all this came big data, where we have like no limit on how much data we can store, right? So data coming from different structures, different format. So all these that we saw before had a uniform format. Like if you see data warehouse, it is all stored as tables, columns, each field has a data type. So it's all structured data was the one we had. But now in big data, we have all types of structured data. The data can be in audio files, video files, images, right? And you can pull up data from Facebook, Twitter, and social media is there. So you get data from even the, like if there are cars in the United States. If you see, the car has a lot of, it sends out information through the internet. So we get emails saying your car is now ready for the next maintenance service. So it tracks the car's performance. Like, so there's data going in from all the devices, like not just specific, like before. It's like totally structured, and it's in different, it is both ways, like structured and unstructured data is used today in big data. So that's the kind of revolution that's happening now, and big data is supported by this. On top of big data, we are now having machine learning, which is a part of the AI, artificial intelligence. So so to understand a little more on what are the various aspects of big data, like, so there is 3 V's they say in big data, right? So it is like high volume, that is you get tons of data every day from devices everywhere, from phones to location data to social media. Velocity is the speed with which you get the data. So today you can track your when you buy something online, you are able to track it, right, at real time. So when they say the shipment has arrived, they give you updates about the shipment every few hours, right? So you can see where the shipment is now. So that's like the velocity of data, how fast the data is getting updated. And the variety is what we talked about. Like, it's not structured anymore. It's like you can pull in data from different varieties, right? So the real-time input from the Internet of Things like IoT, social media, log files, right? That's the key here. And cloud storage and computing, which we talked about. So because of cloud, the storage can be enormous and the computing powers are huge now. So you don't have to buy a server, or you don't have to put money on any of these things. You can just buy them directly from the cloud. So you can have an endless amount of computing power. So you can even query like millions and billions of rows in just few seconds. So which was not possible in the data warehouse or in business intelligence. So in previous times, we always used to have reports that were like for a period of time, like say for 1 month, or for like, the reporting was for 1 year, so something like that. But now we have data which we are going to analyze, which is for many years, like for 10 years, 20 years, all these huge volumes of data we can analyze it using machine learning. That's possible because of cloud storage and cloud computing. So machine learning, so we will talk a little bit more about machine learning in the next slide, but machine learning is, I don't want to go in depth in it, but that's the basic for how all of this pandemic related tools that have come out. So because machine learning is able to understand what kind of patterns are there in the data, it's able to arrive at some meaningful information on how that pattern looks, and it will give you information from the data, which it's not possible unless to look at such a huge volume of data. It's not possible. So machine learning algorithms alone can do that. So we will look at it in depth in the next slide. So machine learning, this gives rise to like 3 types of outputs. Like, it can tell you the descriptive output. So descriptive is more like, okay, this is what happened. So this is the past data, like this is the pandemic, how many people got affected, how many deaths, how many, like the hospital capacities, all those. Like, it just explains what happens. Like, that is that it just gives more information about the past data. And predictive is more like, it kind of will give you a number, like it will estimate, it will give you a very good guess of what is going to happen next. It's going, looking at the past, it kind of predicts what's going to happen next, right? So that is predictive. And the last one is prescriptive, is more like it will recommend, actually it will recommend to you some ideas and suggestions on what you can do. Like when you do shopping, it can recommend some of the products because it knows your shopping pattern. It looks at your shopping pattern, it will give you some recommendations on how you have to, what kind of products you can buy. So with this cloud and all those, it has resulted in a lot of cost savings. So people don't have to invest on their own servers and databases. So they can just afford to use the cloud storage. And because cloud storage is based upon the amount of data and time you use it, you don't have to spend cost if you're not using it. So if you can just, if you're not even accessing cloud, then you don't have to pay the cost at all. So so based upon the usage, you are paying for the cloud. So there's a lot of cost savings involved there. And currently the very key topic in the, like over here in the US is the clinical trials, how they are using big data. So there is a huge amount of research and a lot of tools coming out of this. Like they are able to speed up the clinical trials. So even for the development of the vaccine that we did, it kind of came up in like within a year. So nobody even guessed that the pandemic vaccine will come, within 1 year. So these clinical trials, they are able to speed up these clinical trials because of the big data which we have. So that we can look at it a little more in detail later in the presentation. So big data becomes an input to product development. So we can get feedback about the product, any product. It's just not like related to the pandemic, but you get information how the product design has to be changed. You get feedback from the right here in the US, like Tesla has a lot of, they send signals from their car, and they can actually monitor the performance of your car. So they actually can build a better product the next time by taking the feedback from the cars that they are already selling, so they directly get the feedback from the cars. So it's used in market research as we can, it kind of tells you what products are, they're popular, or what are the shopping habits and other market research. So that's one another area. So let's go a little bit more, just a very basic understanding of machine learning. So I'm not sure how many of you really have studied machine learning, so I want to keep it very simple. So, so what is machine learning? So machine learning is, to make it in a very simple way, to say it's used mathematical statistics to find patterns in huge volumes of data. So machine learning tries to look at the data that we feed it, and you can it kind of tries to find out using a mathematical model. So you basically have to tell the machine learning, okay, use this model to analyze the data, right? And then it tries to find out kind of like a, let's say, in a simplified way, a mathematical equation for the data. So it can now substitute the variables in the equation and come up with a kind of good guess on what will be the next result. So that guess can be, it will be, may not be exactly accurate, but over a period of time, it will keep changing its equation, and it will make it as perfect as possible that the guess is like exactly right to the real answer. So that's the way machine learning works. So we don't have to write a code. Instead, it uses a mathematical equation, or you can say a mathematical model, to link the various parameters in the data. And so it kind of builds that, it kind of learns itself. That's why they call it like machine learning. It's learning because it's able to change the equation parameters, and it kind of comes as close as possible to the correct answer, right? So that's the very simplified definition for machine learning. So there are like 4 ways in which machine learning can be used. So different training methods, like they call it like classification. So you can say, you can show the picture of a picture and say, what is that picture? Is it a picture of an animal or bird, or it can classify that. It can take a decision of, you can even say if you get an email, whether the email is a spam or not, right? So that's the classification model. So it is more or less like it is kind of giving you different categories and classifying the data. So that's one way to use machine learning. Regression is what many people try to use. It's quite common. So regression is, you have the past data, and it looks at the past data using, like, many regression methods are there. So it tries to predict, and say it gives you a number prediction. Like, say you feed data about the price of houses, like, different in an area, in a particular city. So you give data about what's the area of the house, the number of bedrooms, and the how close is the house to the some important like a mall or a railway station or something where the houses values are high. So you kind of feed all these parameters about the house and you tell what is the price. And then there's a new house that's coming up in the market. The machine learning model can like guess the price that will be for the house, looking at all the previous data. So that's the regression kind of model, which it's predicting a number. It gives a numeric output, right? It likes like it's a 50 lakh or something, like it's a number. So earlier one, the classification, what we said, it's going to say like this email is a spam or not. That's not a number. It's actually kind of classifying into some group, right? So that's the difference. And the third one, what we see here, so it is like the recommender is used a lot by businesses today. As you can see, like when you do some Google search on some product in Amazon or something, then immediately you will see the same product coming up in Facebook, right? So then it's also showing up on Twitter or wherever you go, the product related ads start coming up. So how do they do that? So they are able to recommend you something based upon the browsing habit. So they kind of look at all the clicks you make. So like they can find out based on, they can try to understand, okay, this is how you shop. So before you put some product into the shopping cart, so what are the products you did some search, right? So, and then, so they try to find out your pattern of shopping and they will recommend to you something and say, okay, this is what you would like to see. So even when you watch movies in Netflix, so that's a very popular example that you would have seen. So Netflix has this, machine learning algorithm that it understands what kind of movies you like. So it has all this metadata about movies. So whether the movie is an action movie, or who are the actors in it and all that, and it knows what kind of movies you are repeatedly watching. So it will predict and tell you that, this movie, this is the recommended movie, and it will even tell you the percentage of how much it thinks, you will, that's the kind of movie you will like. It will say like 98% we think you will enjoy this movie, so it can predict it based upon your, the way you keep watching movies. So that's the data it is storing and trying to give you a, something related to that activity. So this is mostly used for shopping and other things like a recommendation. And clustering is basically, like you can see, I'm having in the bracket, I said supervised versus like not supervised, right? So that's like, we'll come to that, but clustering is basically finding out patterns without even telling the, like the answer. Like we just want to find out, is there any relationship between the data? We do not know anything about the data. Like we have a group of data, we are trying to see, okay, is there any relationship? And this machine learning model will plot the groups and say, okay, these data points are coming into one part of the, graph. So they have some relationship. So clustering finds out clusters of data, So the earlier three ones, what we said, we give data with the answer to it first to train the model. And then it will give you the answer when you ask a question. So for example, when you do a classification, you want to find out, it has to classify an image. So you kind of feed images about something. Like if you want to classify the image of a plant, so you kind of feed it several millions of plant images. So it learns how to classify a plant. So when you ask for a new plant image, it can find out that answer for you because you trained it. But the last one, the clustering, we are not training it. We are just pushing the data through machine learning and asking machine learning to tell us, okay, what are the different clusters that you see here, right? So quickly I'm going to summarize how this works. So machine learning, starting with, you get the data, right? So you collect data, you divide it into two groups. One is the training and the validation data set. So that's think that is A, like if you have like millions of data coming in, so we take a portion of it and keep it for training and validation. The rest all will be test data. So the one which you selected for training and validation, you pass it through the machine learning, whatever mathematical algorithm that you select, like whether it's classification, regression, or whatever it is. So you train that with this training data. And then the validation data is used for testing it for ourselves before you release it. Okay, so this is the test data. That's different. This is validation, is to say, okay, how did our model perform? So if something is not right here, okay, if you are showing a picture of a cat and the model comes and says it's a dog, that's wrong, right? So we can tune that. So that's what is happening here between training and validation. And once that is done, we will evaluate it by passing the test data. The machine learning model has not seen the test data at all. You only showed it like say 1,000 pictures of cat and you trained it. Now you're going to show another completely different set of cats and the machine learning model will tell you that it's a cat. So that's what, and so that's the testing that you're doing. Now, once this is tested and you get the results as close as possible, then the model is now ready for you. So when you release it, you will get the real life data coming in and it will kind of predict what it is, right? It's a cat or, whether you're using it for classification or whatever it is. So just an overview, machine learning has data collection, it has training and validation data, which are used to train the model and make it ready, like the model is learning. And then there is test data, which you are using to evaluate the model. And once the errors are very little, like you are almost close to correct, then you get the model released and then you will start analyzing the actual real data that's coming in the world, right? So is that okay so far? Do we have any, is that fine? Am I going
Sounds
too
good,
fast?
sounds good. Yes, sounds good, sir.
All right, okay. So with this basic understanding of big data and machine learning, let's go quickly over some of the ways in which the pandemic has, we have used it. So this is, as we heard in the speech earlier, so Johns Hopkins University was the first one I think in January of 2020, they opened this website to track the new cases across the globe. So they were one of the first people to start using the big data coming in from various countries. And we heard this question, have we flattened the curve, right? So that's the question that everybody was asking. So as we know, flattening the curve is a graph between the new cases that come every day versus the days, right? So the day that's in this axis, and the axis here is the new cases that come. So if the new cases is low for a longer period of time, which means we have flattened the curve. So the whole question of flattening the curve came up, and it started with these websites here. And even today, if you go to the Johns Hopkins University website, for every state in the United States, they do these curves very beautifully. You can see that. And very recently, they also introduced the impact of opening and closing decisions. Like there is a graph which shows you how, what kind of, whether we went for a lockdown, and after the lockdown, how the graph changed. Was there any like impact of the lockdown or not? So they did that as well. And the worldwide mortality rate, right? So how many people are dying, and what's the each country wise, what's the rate, mortality rate? So they are doing that. And they also have a very descriptive of like hospitalization. So they can actually predict on how the hospitals are getting loaded with patients. And this model is also used, so that after a few slides, I'll show that. So they're trying to find out how efficiently to send patients to hospitals. Like if some hospital is overloaded, then the machine learning model can actually predict you and ask you to go to a different hospital. So they know the capacity of hospitals and they try to maintain the hospital capacity at the optimum level. So they also have graphs about the tests, and the positivity rate. So positivity rate is the number of people who test positive divided by the number of people you test, right? So it alone cannot tell you much, because if you test very few people, it will give you a very wrong answer. Like, so it depends on how many people you test. So if you test too many people, your positivity rate can be really small. But if you test a few people and you get more positive rates, that doesn't mean anything on its own. So you have to use positivity rate along with the other data. You can't use it alone as a separate thing. And currently, they are with the vaccine being introduced, different states, they have a beautiful graph of how many people are getting, this vaccine has been given. So that's one website which is used. The next tool I wanted to show is the C19 Index. This is an open source AI model. It's developed by a company called closeloop.ai. you can actually go to this website, closed.AI, and it will, you can actually use this data and see, it will tell you an index, like a score. So basically it's trying to predict based on your health conditions, how vulnerable are you to COVID-19. So it's not saying that you have COVID-19, but it's saying, okay, if you have this medical history and these symptoms, and your age and sex and height and weight and few things it takes, it gives you a number like this. It's like you are 4 times more vulnerable, means you might get COVID 4 times higher. The chances of you getting is 4 times higher. So that vulnerability index, it calculates and shows you. So this is also an app. So this is a tool that is used by some of the hospitals and others. They recommend that you first take this tool, and then the tool itself will tell you whether you should go for a COVID test or not. So that's the C19 Index. The other one is a tool developed by the New York University. It's called the COVID-19. It gives you a severity score, right? So basically, this is a little bit more in a detail level. So they take a test result of your, from your sample of, from your the protein in your blood. So these are the 4 types of protein they measure, like, so they call it as the biomarker, right? So they are trying to predict, okay, will you develop severe respiratory issues? So if you get COVID, what are the chances that you will get severe respiratory issues? That's what they're trying to find. So when a patient comes to the hospital with COVID, this machine learning algorithm can tell the hospital whether this patient will require, more, maybe he will get, severe respiratory issues might be coming for this patient. So he might have to get admitted and such things. So from the blood test, they kind of look at the proteins, these 4 proteins, and they also look at the age and sex of the patient. And they started, building this model from China in the early days, from Wuhan. So they took the patients of Wuhan and, looked at their, these biomarkers, and they built this model out of that. So this is for patients who have COVID, and it's saying how severe respiratory issues will come to that patient. So like you can see, it will even give you a score of, that's what it says. Like, so the hospital can now take a decision based on that. So there is this institute in New York here. They call it like the Predict ICU Intervention. They have developed this tool, which is because of the capacity of ICUs. It's very difficult to, if the ICU is overloaded with patients, it's going to be very difficult to manage, right? So they quickly predict how much, chances that the patient might require to be in the ICU or not. So they basically use your chest CT image and other demographic information about you, all the age and other factors, the pulse rate, very simple body temperature, respiration rate, blood test, and it can quickly give you and tell the hospital that, okay, this patient will require to be admitted in the ICU. So how did they do this? They took data of patients in 3 countries, US, Italy, Iran, because these countries got infected in the early months. So they kind of built this model out of that, and to see, okay, how many of these patients, with these parameters, they got admitted in the intensive care unit. So they built the model out of that. So now the model can actually predict if anyone else comes into the hospital, and they believe that the number of people going to the ICU will be very high. Then they can actually order more, beds or ventilators, or they can ask the patients to go to a different hospital. So that's the thing here. And so this model is still under construction. They haven't released it yet, but this professor, Dr. Malik, from the same Polytechnic Institute in New York, he has developed a model which can predict if a city will have a huge outbreak. The peak when will the COVID peak in a city? So he's trying to find out, like, many people don't show symptoms, right? So that's the main problem with COVID, right? If you have symptoms, you can easily track them and put them under quarantine and all that. If a person is not symptomatic, right, a person can still spread the virus. So he tried to find out these people who have not shown symptoms and how significant are they spreading the virus, right? So he tried to build a model out of that, and he tried to say how the virulence of the virus is basically, can this virus bring about COVID symptoms in somebody? That's what. So you can easily say, like, in some countries the virulence of the virus was very less. Although the virus was there, people were not falling sick, right? So they just had the virus, they did not even know about it, they were better, right? But some countries the virus was so virulent, so you got symptoms and you were sick. So virulence means, can the virus make a person sick? So that's the thing. So he built this model to derive these answers, and he tracked the period, the like the 14-day period, like when the virus can actually show those symptoms. And this model also tries to arrive at the rate of infection, how fast will the virus spread in a city. So he did all that. This study is being done by some counties in New York. So basically he's suggesting that if you use this model, you can quickly find out on which date or which month the virus is going to peak in your city. So that's the one of the models. So the other one which I kind of looked at, and this is a very useful model which it's used here, is to capacity predictor. So the main problem in many countries is hospitals don't have enough capacity, right? So there are too many patients coming in, so they can't handle it. So this model predicts, like, how many ICU beds are needed in a hospital, right? How many ventilators and everything related to COVID patients. And it uses the data from hospitals on ICU bed counts, and it tries to, they have the average bed utilization rate, average ventilator usage, and number of COVID cases, testing rate. So there is a website, many websites that there are, I think I have seen a few where they show you that in your state, like in the US, I'm in Ohio, so they can tell all the hospitals in Ohio, and they will predict the hospitals which are going above their capacity. So they will quickly say, if a patient is tested positive for COVID, they will kind of route you to the other hospital where there is enough ICU beds. So this is a very beautiful algorithm which kind of spreads the load, the patient load on different hospitals. And this is very helpful for the hospitals to manage their like equipments and drugs and other things actually. So the Cardinal Health, which I'm working on, is a company which is supplying drugs and medical equipments to hospitals. So we have to be, the hospitals place orders to us and we supply it. So this kind of a quick turnaround of equipments and drugs and other things. So the hospital can quickly predict that their capacity is going high. So they have to order, all the medicines and other things much in advance. So it kind of helps in that actual supply chain of the hospital. And so this is, it's still in progress. I had the opportunity of seeing the demo for this AI tool. It's built by some students from, this is a student named Elton Brazil, and he gave a demo to Cardinal Health. And in South America, basically countries like Brazil or developing countries, the main problem there is Brazil is, as you know, it's very much affected by COVID. So you can compare Brazil with India. The population might be less, but they are the same, kind of other factors. So people don't have, that much. The RT-PCR test, right, which is used for COVID-19, it's expensive, right? So not many people can go and afford the test. So these students there from, machine learning students, they built a model to just identify COVID using your, if you take your X-ray and just upload it on the website, it will just give you an answer saying, okay, you have like 80% of chances that you have a COVID. And he actually did a demo of this. It was very nice. Like he did pretty good. Like, and not only COVID, it can look at your X-ray and predict what kind of a disease you have. Like these 4 diseases he had, like viral pneumonia, bacterial pneumonia, all this. So he kind of analyzed the X-rays of like several thousands of people and built the machine learning model on top of that. So this is like useful for countries, like developing countries, where you can take an X-ray much cheaper, and then you can just upload that image on the website without going to the doctor or anything. It gives the people to get an idea of, if the result comes that, okay, you have 90% chance that you have COVID, then they can go to the doctor and get admitted and all that. So these are students from Brazil who have built it, and that's using the X-rays. So we did talk about big data in clinical trials. So how is big data used in clinical trials? So this is a very a big field that's coming up. So basically in clinical trials, so what's a clinical trial? Clinical trial is they're trying to find a drug or a medicine or a vaccine, and they are trying to say whether it is efficient, it is really working or not, right? So they have to test it first, right? So in order to test it, they need to test it on a correct sample of people, right? So they want to see people who have this disease, that disease, and their age factor, weight, and they have, so all this input criteria they have. So that's why the big data gives them the opportunity. So like you can see here, inclusion and exclusion criteria. So they want to pick a sample based upon all the criteria. So if you say for COVID, like, person has already problem in lungs, right? Or a person who doesn't have problem in lungs, a person has BP, he has sugar, and all those input parameters. So this was taking a long time earlier to do clinical trials, because you have to find out such patients, and you have to form that sample size, test it, and by the time the results come, you have to again load the results and check if the data is actually making the drug is really efficient. Now with big data, they are able to quickly give the criteria they need and pull the sample data and test it on those patients. And it's the important thing about clinical trials, you need electronic health records. Like in the US, most of the hospitals, the data for patients is loaded in the database. Like the hospitals share the data with other hospitals. So if you go to any hospital, they can pull your data and they can get a full history of what happened to you. So even though you may not have gone to the hospital before, the electronic health data is in a centralized location where they can share it with other hospitals. So that's very important. So if a country does not have electronic health records, you can't do this big data in clinical trials. And so this also helps you to find the risk factors. Like they say COVID vaccine, what is the risk involved, right? So they want to find out, is it really safe for patients who have a problem with lungs already, right? Who have problems with BP. So how to find out this risk factors? So this big data is helping in that. And effectiveness of the vaccine, and they have this the study about epidemiological studies. So what is the epidemiological studies? They try to understand where the virus started, how it is spreading, the source of the virus, and they try to understand on which factors, like is there any other factor that is impacting the spread of the virus. So all these studies need huge amount of data to study. So that's where the big data is kind of making those study much faster. And the efficacy of a healthcare policy, if the government comes up with a policy and they want to know if that policy really works, right? Is it really making any difference? Like say, like we saw about when you ask, do a complete lockdown, did lockdown make any difference, right? So earlier we had no way to say whether lockdown made any difference or not, because you never had a full global data to find out, right? But now quickly you can, because of big data, you can run your model and test if the lockdown really brought the number of cases down, right? So that's one of the examples. And it is more like a prediction model. So the clinical trials can, like we said in one of the earlier things, you can also predict how much is the the rate of infection and other things. So that kind of it's used in clinical trials to quickly find out using the data they have. So basically, the reason why we were able to build a vaccine much faster is because we had enough big data available to quickly find the right criteria of people to test the vaccine, and monitor the risk involved and how effective it is. And then, so that's the reason why the clinical trials were much faster in this. And this is an area which is kind of growing, and most of the clinical trials, they are trying to now use big data. But the main criteria here is you need to have data in an electronic health record format first. So quickly going over this important, word that came everywhere, contact tracing, right? So contact tracing, how did machine learning and other algorithms use contact tracing? So contact tracing, more than machine learning, it is more of the way we have used the devices like phones, right? So the phones were the biggest revolution in this contact tracing, right? So we are trying to find which people, like everyone who came in contact with a person who had a virus. So if somebody comes to the hospitals and says, I am having, I have tested positive for COVID, they should be quickly able to find in the last 5 days, who all did I meet, right? And then they should be able to contact those people and ask them to come for COVID test, right? So that's what is contact tracing. So how did we do that? So the cell phone data, right? That's the main thing in contact tracing. Because of the invention of iPhone in 2007, now we have then there was Android and iPhones. We have phone always with us. So contact tracing is going by the assumption that if there is a signal coming from the phone, that person was there at that moment. So it's basically looking at the phone signals to track a person's location. So there are two ways. One is there are, like you can see, I have explained how different countries did that. So some countries collected this data in a centralized location, like countries like Israel, China. So they have more control over the data. So you are giving your location data to the state government or the central government, to the government. So they have the data about your location. They know everything about where you went and what all those. But some countries avoided that because there is laws, and there are concerns about giving the data to the government. So there is data which is localized in your phone. So for example, if you go to let's look at some kind like Korea. South Korea has an epidemics intelligence service. So they look at the phone data and basically they give calls. Like you can see that they started a whole like a call center kind of that's called the Epidemics Intelligence Service. They keep calling people who came in contact with a COVID positive person, and they will make sure that you are staying in the house, like you are already quarantined, and they will track you down every day to make sure you don't spread the virus again, right? So and there is so far Israel actually gave the whole contact tracing, this whole function to their army, like the Israel military service, which is actually used for tracking. And so they were given this whole contact tracing thing. So they were able to track using all the tools they had. So, and in Europe, they are forming a kind of a framework, which is called the Pan-European Privacy Preserving Proximity Tracing Initiative. So this framework can be used by any country in the Europe to, gather information about the location information about people, and then it will be later used for contact tracing. So China had I think you might have heard in news, they have a code, they give a color code like green, yellow, red. So every phone you have to download an app in China, which, then based upon all the health information that you have, it will continuously monitor and give you a code for it. And if your code is red, then in China, they won't allow you to go inside the airport, or you cannot get on a flight and all that. So some countries like Taiwan, they use a mobile phone based and electronic fence. So basically what the government would do in Taiwan is you can't leave your house if you are already tested for COVID-19. They will find out with your location. And if they find out that your phone has moved out of the house, right, you have moved out of a location like a fence, right? So they will give you a call, and they can actually track you down, and that you are not staying at home. So these are some of the ways in which countries have did contact tracing. So you might ask, how did US do contact tracing, right? So in US, the civil liberties, right, the people have more rights. So there was hardly any contact tracing done in the US. The government did not have that much authority to go and collect the data and do this contact tracing. There are many state laws and federal laws which will prevent, and people are very cautious about revealing their data to anyone. So in US, you can't even reveal a person has got COVID or not. So the information cannot be shared in public. So there are few contact tracing apps that came in US, but they all dependent on whether the state government is allowing you to do contact tracing or not. But like in Ohio, I have an app but the app will always throw a message saying you are not allowed to do location tracking in your state. So it didn't much happen in the US because of the laws here. But like you see in countries like Israel, they really gave the contact tracing work to their like full-fledged, the government took over it. So let me quickly go over one major thing about data collection alone. So there are many challenges in this pandemic related to data collection. So I just wanted to bring out a few things. So for example, in pandemic, who is giving the data? Mainly three entities: hospitals, clinics, and labs, right? So in the US, there is a Center for Disease Control which collects all this data. So any hospital that you go, or clinic or laboratory, they have to send the data to the Center for Disease Control. And then the Center for Disease Control will decide what kind of data to reveal to the World Health Organization. So that's how it works. So they submit the data to the disease control, they submit it to the World Health Organization. So there are two types of data they submit. One is like they just collect the total counts, like the case count and the death count. And they also collect more detailed information about a person, like his age, race, like location, which nationality, medical history, travel history, all those, right? So these are the two main data they collect. So in the US, they have a standard data format where different hospitals and they share the data. I don't know if it's a global format or it's only in US, but I don't have the idea much. But so this format is called this HL7. It has a file format in which any healthcare related information can be shared. And one of the challenges they faced in the US is people had a lot of confusion about the data definition. So that's say, for example, date of the disease occurrence. When did a person get COVID? So several people had different dates. Is it the date on which the person came to the hospital, or the date on which the person was tested positive, or the first symptom happened? So there were like so many dates that were used by the hospitals here. So that caused a lot of data problems and other things, right? So the Center for Disease Control really went ahead and defined how the date of disease has to be found, and then you have to say clearly on whether it is the confirmed one, or it's a probable case, or it is just they're trying to, there is a high probability that the person might get. It's just a symptom, but not confirmed. So all those they had to define. So that is one important thing. When you collect data, everyone should define the data in the same way. And what happened in the US is we had some of the entities, they changed the data, what was the defined, like for example, the RT-PCR test, right? So which was positive. So they also included some other test, and if that came positive, those results were also included along with the RT-PCR test, and that kind of the data became bad. Like, so it's important that everybody follows the same definition of data. And not all data is complete. So it is important that you get the full results. So mainly they had problems with lab results coming, which don't have details about a person's medical history, right? And the problem in data collection is, like we said, the data, is it secure, right? No, is it stored in your phone, in your device, or are you, giving it out to the, centralized, it's collected by the federal government or the state government, right? And one of the major things in a pandemic that's very helpful is every entity should share the data, like hospitals, clinics, labs, any public health services, government, WHO. So they have to share the data with each other. So only if you collect the data in a digital format, you can share it, right? So when your data is not in a digital format, it's not going to be of much use. So it's a big challenge in some developing countries, but in US, they have a very good mechanism to share data with all these entities. And we have, there's a protected health information, you cannot share information which, related to you, some of the information like your name and address and other locations, they don't allow to share. So there are several laws related to that. So you have to be careful about these when you collect your data, right? So that's some of the challenges for data collection. Just wanted to point. And so just, I'm just going to close in another couple of slides. So the last topic I wanted to talk about is the government control. Like, how did the governments, try to control the pandemic? So the government has several decisions to make, right? So you have like what areas to lock down, is it really working? Lockdowns effective? About the, should we ask people to wear masks? Is it mandatory? And how do we find out which age group? Like, opening of schools. If children are affected, then the government has to decide about schools. And earlier there was question about the factors about the climate. They said once the climate, once we go to a hotter climate, summer, then the COVID will be gone, or there were a lot of doubts about that. Does the virus change its force because of the climate? So those things, about the flights, this was a big debate on, should we stop the flights coming into the country? Should we allow flights inside the country, like domestic travel, right? Should we allow people to travel between cities? So like, how do we make sure there are essential services, like people have to go to they need food and other things, right? Essential services. So how do we make sure they continue to work, right? And can we open the schools? And how does the government make sure the vaccine production is getting, and vaccine is reaching on all the parts of the country, right? How fast the vaccine can reach on. So these are many decisions the governments have to make. So they need data for all of these, right? So we have to take a balanced approach to that. So there are two thoughts in the one is the people have control over their data, right? It's your data, your medical history, so you have the power over it. So there are laws in the US, like for example, they don't allow others to get this data. So that is, the patient has more control over his data. And then on the other hand, that's the civil liberty we have, right? So on the other hand, the government needs to take these decisions. So the government is telling you, you need to give us this data so that we can take the decision. So there is two kind of debates, right? So that's the major debate in the US here on should we reveal, or how much control should the government take? So some of the ways in which they are suggesting, or some rules to follow, is the transparency. The government should be clear on what data they're collecting and where they will use the data, and collect only the most necessary, minimum necessary data. Don't collect like a huge data, everything. If you're collecting location, you don't have to collect the person's name and everything, but just the location and that very minimum data, which will not reveal that person's personal information, right? And the government should always weigh the public benefits, right, of collecting the data versus the risk, right? And any data that the government collects has to be secured, or it has to be protected. And the data should not end up in, the government shouldn't be using the data to other purposes. This is purely for pandemic purposes, right? So there has to be laws put in place so that the data collected is not misused for a different purpose by the government. So there has to be like clear oversight and accountability, and what misuse related, what are the how it will be controlled and what actions will be taken. And many they are debating that once the pandemic is over, you have to destroy the data that you collected, or the personal data mainly they're saying, not the information about the counts and other things, but if you have collected personal information about people, the post-pandemic, you don't have to, the government doesn't have to hold the data. So these are some of the things to think about, government control versus civil liberty, right? And so let me close this by giving an idea. I just wanted to, I was asked to include this too, because most of you are from the commerce and other background, and you will be taking up more business decision-making roles in future. How does business data help you in business decision-making, not just in pandemic, right? So I want to suggest like 3 things. One is big data is used in business to understand your customer, right? Customer engagement, and to keep your customers, you have to retain your customers. So some examples, like, so today you have petabytes of data. It's huge volumes of data that they are collecting because of online shopping. So it is not just the products you buy, they track every single click you make on the website. So for example, Walmart collects like 2.5 petabytes every hour from their online shopping. And how does like companies like YouTube, Amazon, they are trying to engage the customer is by showing you movies that you like, products that you like to buy. And the promotions that they give, like you will get coupons specific for the kind of purchase that you would like to do, right? So the promotion is not a general, like in olden days, they used to have a promotion for everything, like everybody gets the same promotion, but now it's not like that. Everybody gets a different promotion based upon your shopping habits and other things. And that's so number one is businesses can use like customer engagement based on the big data, study the customer based on the data they have. The second one is now the data is coming at real time at high velocity, high speed. So to give an example, during the holiday season in the US, people used to shop a lot. This company Macy's was able to predict how much crowd is going to come inside their store by looking at the cell phone location of their parking lot, the number of cell phones that are coming into their parking lot. They were able to predict the holiday season demand. And so, and like you can track the fluctuations in your supply chain. So what is fluctuate? So suppose you are a vendor, how efficient is your vendor ready to supply you, right? And how is that? Is there any problem in his the estimated time that he's giving you to supply the goods versus the actual time, right? And if you are getting issues of quality, how do you track it? So all those problems in the supply chain, from the time you're purchasing from the vendor to shipping to your customer, you can track it with the big data that you collect. So one of the airlines here, they found out that the time that the pilot says that the aircraft will land, that is the estimated time of arrival versus the actual time. So there was a gap sometimes of 10 minutes, 15 minutes, or like that. And most of this time, the people were waiting, the people of the airlines, right, to open the doors and let the passenger. So they were waiting there for 15 minutes, and all those times people are standing. So this airlines, they introduced a machine learning base called Right ETA. So it doesn't have to rely on the the ETA that it's given by the pilot. So pilots usually give the ETA based upon what they know. So the flight is coming and they just say, okay, we are going to land in 15 minutes. But then there is so many things happening and it takes long time to land. So this Right ETA collects all the information about the weather and so many other things, and it can predict exactly the time when the aircraft will land. So they were able to save several millions of dollars by allocating their people in the right terminals, not wasting the time. And I gave the example of Tesla before. So Tesla cars come with different sensors. So they keep tracking the performance of the vehicle, and they use it for improving their models. For example, then the Sprint mobile that we have, it can track at real time any errors in the network. So you don't have to wait for the customer to give you a call and say, it's not working. Or if there is an internet outage in your area, Sprint will come to know about it much earlier. So they use the big data to find out. So the third point I wanted to say is, like, now you have this opportunity to get data from non-structured, like unstructured data from all these new channels like cell phones, social media, GPS, the Internet of Things. All these, it opens up a whole new area for you to look at the data. You never had an opportunity to see this data before. So this will give you ideas for new products. So when you gather information from social media, you can understand if people really enjoy your product, or what are they talking about in your product. So you can quickly understand, okay, what should I fix in the product, and I can stay ahead of the curve, right? So companies that were able to understand the data and feedback coming from all these channels were able to improve their product, and they were able to be more, ahead of the other companies. So I also added one quick thing, because you are all in your city in Thoothukudi is very famous for shipping industry. Just out of curiosity, while I was talking to your professor, Mr. Dilip, so he suggested about this, and I just curiously checked how the shipping industry is looking using the big data. Like right in Thoothukudi, most of the shipping industry, this information I just collected from in India. So they use big data to prevent delays in the cargo arrivals. So that's they are saying that kind of in the field of cargo logistics, that saves a lot of time and money, because you can clearly predict the weather and other conditions the ship is arriving. So they can track the way the cargo has got lost, while shipping between different ports. They are able to track what are the reasons for the cargo getting lost. So they are now more reliable cargo delivery is now made. And even the improvements in ship design, they're saying, like the Tesla car we talked about, different sensors, the data about the ship and various maintenance and other data helps them to understand what better ship design we can do. And there's, like, for example, the other part is like transparency and competitiveness in chartering. So chartering is basically finding out, for this cargo, which ship should this cargo should be sent in which ship. So it used to be a very manual effort. So now they're looking at big data and and machine learning. They're saying you can quickly, it can find out the best optimum, the ship that your cargo should be sent. So those are one of the areas I read about it. And other one is the ships travel at different speeds based on the weather condition, and it consumes different fuel. So using the data from the ships, the different data they collect, they are able to suggest what is the optimum speed for a fuel consumption for the ship. And data driven maintenance is like same like for cars. You don't have to schedule maintenance for different parts in the ship based on some kind of a manual or like a schedule every 2 months, 3 months. The difference data which is collected from the parts in the ship, they will tell how much of if it is working properly, or when you have to do the next maintenance. So those signals, it will be passed from that. So these are some of the shipping industry related, which I thought you guys might be curious to know how it's used in your city. So I just brought this up. So that's my all presentation. And this is my last slide. I wanted to show you, for people who are interested to pursue this career on data, you have 3 different roles. You have a data analyst role, data scientist, and data engineer. They are not same. So a lot of times people use the words, they think it's the same, but the job profile for these 3 people are different. I will not go in depth, but let me just tell you what the data analyst does. Data analyst is, he has the data in front of him, so he tries to write queries like, SQL queries, build graphs, and tries to get some meaningful information from the data. So that's what he does. He already has the data with him, so that's what he does. So data scientist is more in depth. He will analyze the data, build a machine learning model. You need to know about math, statistics, or Python and all the different mathematical models also you should know. And you will really design and build the machine learning model. So data engineer is, you are trying to use all the devices we talked about, like social media, all that. So you build data. How do you bring the data from there, right? So this person is the one who will design that interface, design, build, and maintain database, data pipelines, and data processing system. So data pipeline is how at real time, how do you gather data from, like Tesla vehicles are sending data, right? How do you gather the data? How do you store it? What databases you build? So, and this is more of a software computer engineering area where data engineers work. So these are like three tracks I can suggest that you can pick on what it will suit you more. And that's all I had. And thank you very much. This is my last slide. And I thank you for the opportunity. If you have any questions, I'll be happy to answer.
Thank you very much, sir. Thank you very much. Really, it is very interactive, sir. We have learned a lot out of this pandemic analytics. We have came to know about this artificial intelligence, machine learning, and other big data platforms also here in this international webinar. And we have a few questions from the students' part. I request Ms. Ruby Angel from 2nd PBA to take out this query session.
Good afternoon, sir. We have few questions from the participants. First question, sir. How Bayes theorem is useful in... Good afternoon, sir. We have few questions from the participants. First question, sir. How Bayes theorem is useful in the machine learning context? First question, sir. How Bayes theorem is useful in the machine learning context?
Okay, sir, we kindly request you to unmute yourself. Yeah, we are doing, sir. 2 minutes, yeah, we are doing. Are you able to do it?
Yeah. Okay. So I didn't know that I can't unmute, so I muted myself. Are you asking about the specific theorem?
First question, sir. How Bayes theorem is useful in the machine learning context?
So I don't have a real ready-made answer right now. So I think so Bayes' theorem is more related to the probability calculation, right? So I have not really don't have a quick answer to give you on related to what the theorem says. So I'm sorry that I don't really have that full definition for that theorem right now, but I know it's related to probability, but I don't have the mathematical answer to you on what it's used there.
Next question, sir. What is deep learning context with machine learning algorithms?
Can you repeat again?
What is deep learning context with machine learning algorithms?
So yeah, so within AI is a whole umbrella, right? So we have neural networks, we have so you can say that deep learning will be able to, it's an extended form of machine learning where it will be able to even find out very minute, complex interactions of data. So you can say it's an very advanced method of machine learning. So we also have like deep learning, there's neural networks. The neural networks will stimulate like how the brain works. So they have different layers of nodes where the data is passed between different nodes, and there are decisions taken in different nodes, and you can it tries to arrive at a more when you have so many factors that derive the machine learning final output. So you have the neural networks there. So same way, deep learning, in a simple way to say, it is a mathematical model. It's an advanced level of machine learning which can help you to find out even the minute relationships between data.
When should we use classification over regression?
I couldn't hear the question. Can you repeat?
When should we use classification over regression?
So the question is like, when should we use classification and over regression?
Yeah. So so the easier way to remember this is classification. It gives you a category answers. Okay, this is an easy to remember. Is this is a cat, or this is an animal. This is a you are showing the picture of a plant. It will tell you what plant it is. So it's classifying that, right? Regression is, it gives you a number, a numeric number. So what will be the price of this car? You want to find out, like we said, for example, what is the COVID-19 index, right? What is the probability that the person will go to an intensive care unit? So it's a number. It kind of gives you a calculated number. So when you want to use a calculated number as a result output, you use linear regression. For example, linear regression is the most popular. So you pass the past data, and it arrives at the linear regression mathematical equation, and it gives you a number to predict what will be the, for the question. So classification is a group. You are asking whether the email that you received is a scam or not. So it has an answer like yes or no. It's not a number answer. It's not a numeric answer. It's a classified. It's a classification. Is a group answer. Yes, or you put all these emails which are scam or a spam into a group. And so easier way to imagine is, remember this is regression gives you a numeric output, whereas classification is giving you a category of output. Is that clear?
Thank you, sir. Next question, sir. How would you evaluate a logistic regression model?
So in general, when you say evaluate, are you asking the process? How do you evaluate?
Yes, sir.
So the process of evaluation is basically, for any regression, whether it's a linear regression or a logistic regression, you divide your data into training set versus validation set. So, and the training set basically is what you will actually train your model using the if it's a linear regression or logistic regression, it kind of, you input the training set and it arrives at the particular, and mathematical equation to, tell you the answer, like the predict. So the validation data set is to check whether your training data set is good or not. So basically, when you evaluate, you pass a new data set called a test data set, which the model has not even seen. So it's the same, the method of evaluation is the same for all regression. It doesn't matter whether it's a linear or logical, logistic regression. So the important thing here to remember is the model should not have seen the test data. So whatever you have in the test data should be completely unknown to the model. So you only use the training data and validation data first, and you get the model ready. Then you suddenly pass a completely new set of data called the test data. Then you evaluate and see how the model is able to predict. So the method of evaluation, I think, is the same. Is that fine?
Thank you, sir. Next question, sir. Do you have experience with Spark or big data tools for machine learning?
So we use Google Cloud related machine learning mostly in Cardinal. So I know many companies use different. So I use Google tools mostly. For example, there are like Google Cloud related machine learning tools which they have. So I don't have really used the Spark, I think, but it depends on the company where you work, whether you are using specific tools. So no, I have not worked on that.
The final questions are like, it is a question from my part, because there are data as power again, and the entire world is been with the data nowadays. So how far we can secure this data? Because when you're talking about this pandemic analytics again, every country has its own database, like how many of the people have been died due to this coronavirus, and how many of the people have been undergoing the medication process and all those things. So how can we secure this data?
So so basically, the cloud technology, when it came, people usually were really very, worried about how do you give the data to the cloud, right? So earlier you were storing the data in your local server, right? In your local database or anywhere. So then the cloud technology came, and then you are storing it in the cloud somewhere. So what is cloud is like, for example, we are using Google, right? So Cardinal Health, Google, all the data is sitting in some Google data center located in some part of the world, right? And Google may not even reveal to you which data center has that. So there was a lot of, people were worried, okay, I'm giving the data to Google, will it be safe? But then if you really think about it, do you ask, if the data is sitting with you, you have the data, how secure it is, versus if the data is with Google, how secure it is? So what Google is arguing is they have more sophisticated methods to keep the data secure, versus a person like us who have our own company, our own server, our own database. So Google has got more advanced method of data security. So the cloud itself has become more secure, like the data at rest and data in, so everywhere Google gives, like, data security options by default in the cloud. I'm sure the other cloud providers will be doing the same. So the data centers have a lot of layers of security. So with all that being said, the data is now more secure with the cloud providers compared to how it was with the people or individual people or with the local companies. So the cloud technology itself has brought about some security in the data. And so that is the one thing we can be, we can rely on, that the data is secure when all this pandemic related data is stored in the cloud. But the other question is more on like, it's not more about a technical challenge. Of course, the cloud is more secure than this, but more on the other side of like, how will the data be used by somebody who has it? So it's an open question, like how the government can, who has your data, what can they do to track you down? Tomorrow, if you commit a crime, they can find your location using the data you gave during pandemic. So just a weird example. So that's why they are saying the pandemic data should not be used for another purpose, which is like tracking down crime or somebody's, details. So don't use it for other purposes, but just use it only for pandemic related. So those are kind of rules and regulations have to come. But in general, to answer your question, I think the cloud has given more security to the data today. So as long as you use cloud, I think you are good. Like most companies have got data hacked when the data is stored in their own servers, but hacking a cloud, it's quite impossible nowadays.
Thank you, sir. Thank you very much, because really it was again indeed a great privilege for us to have you here and have gave an informative session for us with the queries whichever is asked to you. Really, it was. I hope it was answered well and good, sir. Thank you very much. And now it's time for the feedback session. I request one of our student, Ms. Bhagavati of 2nd BSc Mathematics, to leave her feedback.
Sir. Good afternoon, sir. Really, it was highly informative, and we have learned a lot out of the information. We have, sir, recently our college has integrated mathematics with analytic concentration. I hope really this is a great eye opener for us to the certificate course in the analytic stream. Thank you very much for the information section. Again, sir, thank you so much.
Thank you.
Thank you, Ms. Bhagavati. I request one of our first year student, Mr. Krishnamurthy, to kindly leave the feedback.
Good afternoon, sir. Being the student from BBA and BCom, it is really a great section for us, sir. We have learned a lot from your section, sir. The advancement of data analysis, how TAN does pandemic data analytic during the pandemic breakout. This section helps us to do more research as well as extra advanced studies to learn about the machine learning and by data platform. Thank you very much, sir, for the nice section in which we have enlightened. Thank you, sir.
Thank you very much, sir. Now I request Dr. T. Sangeeta Sudha, Organizing Secretary of this international webinar, as well as the Academic Coordinator of the Department of Commerce, to lead the vote of thanks. Ma'am, it's not audible. People switch on a phone. Sangeeta Sudha ma'am, we can't able to hear your audio. Can you please come down?
A very pleasant good afternoon to all. I did it the great honor and privilege to propose vote of thanks on these memorable occasions. So I like to thank to the Almighty God for the making today's occasion a resounding success. On behalf of Geetha Jeevan Arts and Science College, we express our heartfelt gratitude to Jeevan Rathinam, Senior Engineer, Data Architect, the Coordinator Health Incorporated, the Gloveland, the Ogio USA, for his the valuable rendering on this topic, the pandemic analytics. How data is the helping us combat COVID-19. So thank you, sir. Thank you for the interesting and valuable information. It is indeed a great privilege for me to thank beloved Secretary of the institution, the Mr. P. Jeevan Jacob, sir, who granted permission to conduct this program. Thank you, sir. A warm thanks goes to the principals for your vision and commitment to work. And it's the execution high benchmark you have set for the ourselves. And never say die, attitude help us to excel in all endeavors. Thank you, madam. We would like to thank our IKC coordinator of today's webinar, Mr. Dilipan Kumar sir, Head and Assistant Professor of Business Administration and Commerce. He has been the constant helping in the making this webinar a grand success. Thank you, sir. Last but not least, I like to thank our faculty and students of our college for your cooperation in making this webinar a resounding success. Thank you once again. Thank you and all. God bless you.
Thank you very much, sir. Thank you for joining with us today. So hopefully we have Department of Mathematics in our institution. So as yesterday in the telephonic conversation, I was intimating you about the integration what we have for this mathematics. So we would also like you to add as one of the academic advisory board member of our institution, so that in the coming days, when you're talking about the big data platforms and machine learning, it will be very grateful for our students, especially in particular for the students of Department of Mathematics. It is very blessed for them to know more about this IAA, ML, as well as BD concepts. Thank you very much, sir. Thank you for joining with us. Thank you very much, sir. Again, on behalf of the entire GJC family, I thank you, sir. Thank you very much.
I really enjoyed the session and thank you very much for inviting me. Thank you.
Thank you. Thank you, sir. Thank you.